Before I do this, I want to emphasize that this cell has been fully discharged to 0 volts. As a result, the battery has no charge and it's completely safe to dissect. Now first, I had to find a way to get into the battery without damaging the lithium. Cutting into the positive terminal gap made the most sense since this was the thinnest part of the battery, and the anode and cathode did not extend above this gap. Now the first thing we can see is the lithium wrap and retainer. If you look closely, you can actually see carbon fiber composite mix in the retainer. This helps reduce the weight of the battery by a tiny amount, which helps improve the energy density ratio. Now the positive terminal itself has 3 small vent holes, which helps release pressure due to a change in altitude or cell failure. Here we can see the O-ring, which allows the cell to remain hermetically sealed so that water cannot get inside. The black dust you see falling off here as I unwrap this roll is the electrolyte. Now this tightly rolled up part of the cell is called the jelly roll. Since the inside of the battery is dry, nearly all of the material, with the exception of the electrolyte powder, can be recycled. Additionally, there's no acid that we have to worry about. So these are the 3 main components we found inside a lithium-ion battery. Now, the first 2 of these are essentially the positive and negative inside the battery. Now, the first of these is a simple copper foil, very, very thin, about 1 meter long. And the second one of these is your lithium. It doesn't look like lithium, but it's inside this coating. There is a very thin amount of lithium. And one other thing is that this is covered in electrolytes, which basically stores the energy of your battery, of your lithium-ion battery. And then we have a simple plastic wrap that goes in between these 2 pieces to prevent them from touching. Because if they touch, well, obviously your battery is going to short circuit. Now, one thing I want to note about this piece is that this is basically where all your power is. This is the positive. Your copper here acts as the ground, so there isn't much power here. But this is where the potential of the lithium-ion batteries and also the danger. Now, this can actually catch on fire quite easily, and I'll show you that in a few seconds. But one thing that has been done is people have thought of adding fire retardant in between these layers. And the one problem with that is that will mean that your battery size needs to be increased. And that's a big problem because you don't want to have a heavier battery. You want to have as thin of a battery as possible. And your jelly roll, which essentially when you roll all these together and fit it inside your battery, you want that to be incredibly thin. So the main advancements in battery technology are coming in between these 2 areas. First, how can we get this copper foil to be thin? And second, how can we get this lithium foil to be thin while still retaining a good amount of energy? When lithium is burned, it is extinct. Bright red color is produced. Higher temperatures produce plasma.